Okay, so let's get started for the day. You took your first exam last week on the computer on Canvas or online. You already have another exam next week, but on Thursday we'll go over more details about that. You'll have another exam. Remember, because we're doing two courses in one semester, you have twice as many exams. So we have basically exam every 2 weeks, even a little faster than that at some points. So your second exam will be next week, but I'll give you more information about that later. Your third exam is the week after, but there's a huge but about that one. That exam is going to be our self-paced exam. It's not going to be taken where you have to have the webcam and you have the limited time like that. That's going to be an exam found on MyLabs Plus. You have an entire week to work on it. You can work on it in parts even. You can work some of it on one day, some more on the other day. And on each problem, you'll get 3 attempts. But unlike the homework where it'll refresh as many times as you want, the exam won't do that. You get 3 attempts on a problem and that's it. So it's a lot more lenient than a regular exam would be, much more, but not quite as lenient as a homework assignment. And so that's what we're going to roll with. Your exam 1 grades have been put into Canvas. What you see now is your grade after I went in and applied any extra points based on the work you submitted, your scratch work that you would have submitted to me. So that is good. Do you guys have any questions for me? Any questions for me? Comments, concerns? You have some homework. I'll be opening up some more homework as well today. Okay, so we are doing chapter 6 now, and so far chapter 6 has been concerned basically with linear equations of some kind. And so far, we've really only dealt with linear equations in one variable. So let's talk about what happens when we kind of graduate from that. Or what we need to do is we need to set up applications. Applications. What an application is a real world application. It's a real world kind of thought about how we can deal with linear equations, how we can set them up, how we can solve them, what does solving it mean, what does the value of the variable mean when you solve for it, and so on and so forth. And so that's what we're going to be concerning ourselves with today. So that is kind of a fancy way of saying we're going to be dealing with word problems. Word problems. Now, as most of you know, word problems can be the most difficult types of problems you see. They can be a blight on your happiness, as most of you are probably aware, I'm sure you are. And that's because word problems ask you to not just do a mechanical process, which is solve the equation. They actually ask you to set the equation up yourself and then solve it and figure out what's going on. How are you modeling things? They really task us with kind of opening up the highest parts of our brain cells, or functions of our brain, in order to understand them. So let's go over a good general strategy for solving word problems. Read the problem carefully several times, until you can state it in your own words, what is given and what the problem is looking for. Let X, or really any variable, represent one of the unknown quantities in the problem. You may see application problems where you're going to have multiple variables because there are multiple things that are unknown. And you're going to have to try and model them, make an equation for them, figure out what it takes to solve them. If necessary, write expressions for any other unknown quantities in the problem in terms of X. So what you're going to see is that there may be multiple unknown quantities, but for the level we're at the moment, we've only been equipped to solve one variable problems that just have X, things like that. So that means if there are other unknowns, you can't use Y's and Z's and W's. You can't have more than one variable after the dust settles because you don't have the tools yet to solve something with multiple variables in it. The next thing you need to do is actually write an equation that models the conditions of the problem. Then very likely you're going to be solving that equation. Solving it means isolating x, figuring out what value or values make the equation true. And then make sure that the solution makes sense within the original problem that you have. This is a good strategy. I would write these down. I would review them pretty much any time that you are doing a new kind of problem, anytime you're dealing with a word problem of some kind. Look over it, read over it, and deal with it. Okay, this is one of my favorite tables in the whole of this course, because what we're going to do is we're going to have to convert things. We're going to have to think of ways that we can create problems. We're going to have to think of the words that we can see in word problems that cue us in as to what the heck we got to do here. How am I going to set up an equation? Is there addition involved? Is there subtraction involved? Well, do you have your four principal operations: addition, subtraction, multiplication, and Tom Clancy's the division? What you're going to do now with these four operations is you're going to see words that are usually tied. So with addition, the word sum, not sum 41, just sum, S-U-M, pretty much clues you in on addition. The sum of something, of two things, three things, four things, the sum is the result of addition. After you do addition, you call the result of it, you call the answer to it, the sum. You might also see more than, like 3 more than x. That would say x plus 3 in that context. More than can be a little bit deceitful because it can also sound like an inequality, the greater than sign. So we'll just have to know when to do what ourselves. Then increased by, the word increase, usually it means you're thinking of addition. You're increasing something, so you're adding on to it. You could argue maybe that goes with multiplication. It just depends on the context. Subtraction, okay, so in addition, of course, you have the word plus can be thrown in there, naturally. For subtraction, the word minus. If you say 3 minus 4, 17 minus 5, you're thinking of subtraction. You're thinking of subtracting the second number from the first number. Decreased by, if you decrease one value by another, you're doing subtraction. Of course, the phrase subtracted from should make you think of subtraction. Difference, the word difference, difference between, difference of, should make you think subtraction. Less than, when you're saying it's 5 units less than X or something, you have to be careful because that could be like a less than sign, an inequality sign. It just depends on the context. Sometimes that can mean subtraction or fewer than. Multiplication, a lot of people like to just call multiplication times, but yeah, I guess that's not terrible. The word times can apply here. Product, the product of two things. Whenever you do multiplication, the result of it is a product. It's a product. If you take a percent of a number, remember we discussed percents in length last time when we did our little bit of review before the exam. We also covered some new material. If you were not able to make it last time, you can see the YouTube video on the YouTube channel. How many of you in here or in the Zoomosphere, how many of you have gone to that YouTube channel and looked at some of the videos and seen it? Hopefully it's helpful. If you're coming to class and you don't need the YouTube channel, that's fine too. But hopefully you're utilizing that YouTube channel. Of course, you can find the link to that channel in the Canvas modules. Thank you very much, Gabriella. I'm glad it's helping. I'm glad that the YouTube is working out for you. So YouTube's nice. So multiplication, if you say you're taking a percent of a number, well, if you want to take 86% of something, you multiply it by 0.86. We discussed that last time, if you'll recall. So taking a percent, we'll deal with more examples of percents at some point here soon. Multiplied by, of course. And when you say you're taking twice something, you're multiplying it by 2. After that, there's the word thrice, which is taking 3 times a number. And then I don't know what 4 or 5 or 6 times is. I don't know what the words would be after that. So there's twice and thrice. Finally, if you're talking about the division, You can say it's divided by a quotient of two things. Remember, we mentioned what a quotient is. I'll write it out here just for fun real quick. You'll recall when you're doing division, let's say you're taking the number 12, you're dividing it by 3. Of course, 12 divided by 3 is 4. The different terms we use, 3 is going to be called the divisor. It's what's doing the dividing. It's what you're dividing by. The 4, the result of division, is usually called the quotient. And then the 12 has a funky name, the dividend. It's what's being divided. So there you go. So if you see these terms going on in a word problem, you're probably going to have to use division of some sort. I would bet dollars to donuts that you would. And then the word reciprocal, remember, if you started with a number like, how about negative 1/4? It has a reciprocal of negative 4. Technically, it's negative 4 over 1. You flip the fraction. You keep the same sign, but you flip the fraction. Of course, negative 4 over 1 is just negative 4. So if you think reciprocal, what you're actually doing is you're dividing it. If you were to divide by 1/4, you're actually multiplying by 4. Or if you multiply by 1/4, you're actually dividing by 4. So reciprocal kind of makes you think about division in a way. And that's just that. Okay, let's ignore this one. Well, we can talk about it. I can put a little commentary on it. How many of you want to hear my commentary? Anyone? If Terry was a common name, you'd call him Commentary. So, yes, my jokes are lame. How many of you have figured that out? You figured out my jokes are very lame. Has anyone figured that out? And guess what? I can be funny. I can be really funny. I can make everyone just laugh in here. Well, thank you. I appreciate that. Some people do think I'm funny. Well, you know, you're surprised every day by new information. Some people think I'm funny. I appreciate that. I'm slightly funny. Like if people say, how funny are you? I say like a 6 out of 10. Like I'm okay. It's not great, but it's not the worst it could be. Okay. So on the bar graph, so this word problem, we're just using the bar graph to kind of relate the ideas here, but we're not actually going to use much of the information from the bar graph to actually do the problem. There's just some interesting thoughts here. The bar graph shows average yearly earnings in the United States by highest educational attainment. And so we can see the differences. They plot male and female on here, and the average yearly earnings. This was probably a number of years ago because inflation raises everything. But at the time this was come out, the average female who did not have a high school degree would make about $16,000 a year. The average male would make $25,000 a year. Now, I know what you all are saying, the wage gap, if you're aware of those kinds of arguments in the news. There's actually some data. We could have a discussion about the wage gap if we wanted to, but just looking at these data. For a high school graduate, the number goes up a little bit for females. It goes up a good bit for males from the previous. So remember, you're jumping for females from 16 to 25,000. So you make about 9,000 more per year if you go ahead and get that high school diploma or the equivalent. And then you can just see the bars are slowly going up as you attain a higher level of education. Now, that hopefully shouldn't be super surprising news to you. I assume that's why pretty much all of us are in here, right? You're wanting to get an education, but frankly, you're wanting to get an education so you can get a better job, right? You can get a better job than what you would without an education. And you know what? I'm a supreme capitalist American, and I say there's nothing wrong with that. There's nothing wrong with getting a better job. That doesn't mean you have to make necessarily, oh, I got to be rich someday, but you definitely want to make enough money to support yourself, support your family, you know, make sure there's food on the table, roof over your head, all those things. How many of you know that all that stuff ain't cheap? This stuff is not cheap. It is not cheap keeping a roof over your head. It requires a lot of work. So higher levels of education do come with higher earnings, higher income. Okay, well, so we can see that relationship here. So now, the average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. The average yearly salary of a man with a master's degree exceeds that of a man with an associate's degree by $45,000. Combined, a man with an associate's, a man with a bachelor's, and a man with a master's, on average, their combined salary each year will be $214,000. So that's for 3 different people. So find the average yearly salary of men with each of these levels of education. Everyone say, So here's what we don't know. I hate that this thing squeaks. It is a blight upon humanity. Here's what we don't know. Assuming we didn't have that bar graph a second ago and that all we had was this word problem. What we don't know is how much a man with an associate's makes on average. That's one thing we don't know. Here's another thing we don't know. How much, and I just love typing, a man with a bachelor's makes on average. We don't know that, do we? We also don't know how much a man with a master's makes on average. We don't know how much each of them make individually, as you can see from the problem. All we know is that someone with a bachelor's makes $25K more than someone with an associate's on average. And someone with a master's makes $45K more than someone with an associate's on average. So you think, well, there's 3 things we don't know that we're trying to figure out. So don't we need 3 variables? You can maybe use X, Y, Z, or A, B, C, or whatever floats your boat. Normally I'd say, yeah, you'd need 3 variables because you have 3 things you don't know. But you're going to exploit this relationship you're given, that the different amounts they make. So here's what I'm going to do. The amount that a man with an associate's degree makes. No, I want to go back to that text box. You let me in. Well, it doesn't want to let me in. We're going to say that the amount a man with an associate's makes, we're going to call it X. There's probably a better way to do that. Let's just go into a whiteboard. So, yearly salary for associates, we're going to call that X. And it makes sense to let this one be the variable because the other 2 are based on that, right? The other 2 say, well, a bachelor's makes $25K more than an associate's. And a master's makes $45K more than an associate's. So it sounds like the associate's degree salary is what should be our baseline. So I'm going to let that one be the variable. This means that the yearly, yerky, sounds like a word from Boston. The yearly salary for a bachelor's, you're tempted to say, well, that's going to be Y because I don't know what it is. So I'm going to have to use a new variable. But let's do it a different way. Not 45, but 25. Exactly. Very good. That's exactly right. So you think, well, I need a new variable. No, you don't, because you were told that someone with a bachelor's makes $25,000 per year more than someone with an associate's. And X is the amount for someone with an associate's. Let's make it a better plus sign. And now remember, this is in thousands of dollars. So I'm just going to add 25 instead of 25,000 just to keep the numbers simple. And we'll have to know offhand, well, this means thousands. Very good. So actually, we don't need a second variable. Yearly salary for masters. We know that's 45K more than the associates. The associates we're calling X. So we know the yearly salary for a master's is X plus 45. And so we don't need X, Y, Z. All 3 of these are just X. because as it is written, X is going to give it to you. And so now we have these three things. Now, do you guys remember, and maybe we'll have to go back here. We remember that combined, if I added all three of their salaries together, it would come out to $214,000. In other words, if I do this one plus this one plus this one, what should that equal? 214, exactly. If I do the salary for an associate's plus the salary for a bachelor's, which is not just X, but it's X plus 25. Now you could put it in parentheses to say it's its own separate quantity, but all we do is end up dropping those parentheses anyways because we're just adding it, and we would just be doing 1 times it, it wouldn't matter. And then plus the salary for a master's degree, which is X plus 45, all that needs to equal 214. So all we did was we established a variable. In this case, we tied it. And look what I did. I openly labeled it. I wrote out in plain English what that variable was. I didn't just say, all right, X. No, I said, no, X represents the yearly salary for an associate. I would urge you to set your word problems up just like that. I would strongly urge you to do that. And then we said, all right, now that we know what each of these things are, now we can actually make the equation out of them based on the information given to us in the problem. And bada bing, bada boom, we set up the equation. Now, if we solve this thing, what we're doing is we're isolating that value for X. We're figuring out what the value of X is. And once we know that, we'll know how much a yearly salary for associates is. Add 25 to it, and we'll know the yearly salary for a bachelor's. Add 45 to it, we'll know the yearly salary for a master's. So it all kind of falls like dominoes. So now we actually need to solve this. What should we do first? Yeah, all your X's, all of whom live in Texas, you want to combine them together. You want to combine like terms on the left-hand side. It just kind of makes sense because that way we're condensing it. So I've got 1, 2, 3 X's. Actually, I only have 1, personally. And then we've got 3 X's over there on the left. Then we've got 25 and 45. We add those. Maybe you can do it in your head. Maybe you can't. You're free always to do. It'd be 70. Yeah, you're always free to do kind of your old school. 70 is exactly right. Thank you, Gabriella. There's nothing to do on the right-hand side. Now, this looks like kind of a better form of our equation. Now what do we do? Exactly, we got to get rid of 70. We got to isolate the variable. So yes, subtract 70 from both sides. Very good. Menos 70. It's been a while. We subtract 70 from both sides. We're still going to have the 3x. 214 minus 70. Again, you can use kind of your doing it by hand. But yeah, you'd get 144. Yeah. Now what do I need to do to both sides? Divide by 3, exactly, because that is keeping the x from being by itself. Now you're tempted to use a calculator here, but you don't need to. You can do 3 into 144, you get 48. That is correct. But you don't need a calculator. You'll get 48 for x. Very good. So are we done? Yeah, we got all the pieces have to fall. But we've done all the hard work. We've done all the heavy lifting. So all we got to do now, we already know for the associate's degree, we know that it'll just be 48. So on average, a person with an associate's degree makes $48,000 per year. Now, average means there's some who are going to make below that, some who are going to make above that, some might make exactly that. For a bachelor's, what we're going to have to do, well, we know what x is. Exactly. You got to do x plus 25, so you got to do 48 plus 25. That should give you what, 73? So long story short, on average, someone with a bachelor's degree, which is kind of a standard 4-year degree, though sometimes it can take longer, is $73,000. That's certainly a nice improvement. Who wouldn't want to make 25 grand more per year, right? Everyone wants to make more money because money's the most important thing in the universe. That's not true. That's not true. But it certainly can lead to a more comfortable life. And I think we've all learned that lesson the hard way because it's not fun not having money. But sometimes we have to deal with that situation, especially during these very unfortunate times with COVID. Things have not been a lot of fun. Finally, we're going to get the master's degree. So it'd be 93, yeah. Which means that someone with a master's will make $93,000 per year on average, which is $20,000 more than just a bachelor's degree. And it's $45,000 more than an associate. So we can kind of see how all the pieces have coalesced here. We've got some unknown things. We make an equation. We try to make sure everything's in one variable. If it's not, at this point in the game, you're doing something wrong. We will later on get into 2-variable equations. We won't quite get into 3-variable equations, not in the true spirit of them, but yeah. Did that make sense? Everybody in here and everybody in the Zoomosphere, did that make sense? I certainly hope that it did make sense. Again, of course, you can always review. Thank you very much, Nicole, Esmeralda. Again, you can always review this video. Look at it later. Back to the PowerPoint. So yeah, they just set it up exactly like we did. So, it's important to do this kind of reasoning. This is fairly basic stuff, pretty straightforward stuff so far. This kind of reasoning builds up your logical reasoning, builds up your ability to make decisions, to make proper decisions, to think about things clearly. And so that's kind of what we're doing here. One side note that has nothing to do with math, I decided to get rid of my cloth mask. You might remember I had that cloth mask, and I used just the standard blue paper masks. And oh my goodness, they're amazing. They're ranked as like the second best mask behind the kinds that like surgeons use, and those are expensive. They're like triple layered. Nothing can get through them pretty much. They're light and easy. So I am really enjoying this paper mask. If you think the mask has been cumbersome and annoying to wear and you're breathing, trust me, I get it. And try considering a paper mask. It just incidentally, I actually just bought stock in a paper mask company. So I do stand to benefit from you guys buying paper masks. That's not true. I didn't do that. How many of you believe me? I don't know. He could be like, yeah, you never know. Yeah, there you go. That's a good answer. You don't know me well enough yet. Yes. No, I did not buy stock in a paper mask company. I just really like my paper masks. Okay, so it would be a great investment, Nicole. I agree, especially right when COVID hit, because you could buy it at a cheaper amount than now. But even so, yeah, buying stock, buying investments in cleaning industry and all that business, yeah, this is the best time for that. Okay, so moving right along, selecting your monthly text message plan. Let me preface with, some of you are like, what is a text message plan? Well, you see, youngins, in the old days of like 2005, when cell phones were first becoming, now I know you guys were around, but when cell phones were first becoming a thing, you actually had to pay for your text messages separately. And sometimes they would just charge you per text message. Now, anyone under the age of 25 knows that would be thousands and thousands of dollars a month if they actually charged by text message today. So it's a little outdated, but that's okay. So am I. So we're going to solve this one together. So you have 2 texting plans. Plan A has a flat monthly fee of $20, and on top of that charges 5 cents per text. Plan B has a monthly fee of $5, but charges a little bit more per text. So you can tell, if I go with Plan B, if I don't really text all that much, like I send maybe like 10 to 20 text messages a month, you probably see that Plan B is the better one for you, right? Because it's charging less up front. It's only charging $5 up front. It charges more per text, but you're not likely to end up spending more than if you went with Plan A. But if you are the texting sort, then you would definitely want to go with Plan A. If you text all the time, if you send thousands of text messages a month, Plan A might have a higher upfront cost, but because it costs less per text, it might in the long run end up being cheaper for you. So it just depends on how much. Well, here's what we're going to do. We're going to figure out the amount of text messages you could send each month for which Plan A and Plan B would be the exact same cost. We're going to do that. And then after that, you know that if you text more than that amount that we're about to solve for, you should go with Plan A because it's cheaper per text. And if you send less than that many texts per month, you should go with Plan B. So let's see. Let's ask a few questions about this. What if Plan A and Plan B, what if Plan A charged the $20 per month and Plan B charged the $5 per month, but what if Plan A and B both charged 5 cents per text on top of it? Which one would be the better plan in that case? Plan B would be, if they were both charging $20 a month straight up? Oh, no, I said 5. If they're both charging $5 per month, so in other words, we change Plan A's base fee from 20 to 5. If they're both charging $5 a month, but Plan A is charging 5 cents per text and Plan B is charging 10 cents per text. Exactly, clearly A would be better. No matter how many text messages you send each month, Plan B would cost you more money. The only reason there's even a comparison between the two is because their base fees are different. Let's say Plan A kept charging the $20 a month, but charged 10 cents per text, and Plan B kept charging the $5 per month, but also continued with that 10 cents per text. Which plan would be better? Plan B would be better, because either way, you're paying the same amount per text, but you have a lower base cost with Plan B. So the only reason this problem is interesting is because one of them has a lower base cost, but the other plan has a lower per text cost. If they were the same in one and then the other one was different, then it would be just a slam dunk which one you should go with. That's the only reason this problem is interesting. Okay, so let's see here. Let's just type out what we've got. Plan A was a $5 per month, $20 per month base charge. You're going to pay that no matter what. After that, they were 5 cents per text. Plan B was a $5 base charge. You're going to pay that no matter what. But they charged 10 cents per text. For how many text messages are they the same cost to you, the consumer? How many text messages? Basically, if you send so many text messages, how long till you're tied? So it says for how many text messages. So it wants to know that number of text messages. It wants you to tell it, hey, so your unknown, the thing you don't know that you're trying to figure out is how many text messages you could send per month, at which case these would be tied. So that's exactly the motivation why we're going to make X that value. We're going to have the variable X, and we're going to say that X is the number of texts you could send each month, technically, to where both plans cost the same. So here's what we're going to do. If that's the case, we're going to set up a cute little table here. tables and ladders and chairs, if you watched wrestling in the late 90s, which I did. I remember being 11 or 12 years old, and I'd watch wrestling because I got to see dudes pretend to hit each other, and it was really awesome. So, let me get this adjusted properly. Why are you not doing that? You do not need to be mean to me today. Okay, that works for me. Okay, so what we're going to do is we're going to have this little chart, and then over here, I'm going to put cost of plan. Well, the plan, it depends on how many texts you're sending each month. We're going to let X be the number of texts you send in a month, and we're going to try to figure out what it takes for it to be the same for either plan. So the cost of the plan is going to be $20. No matter what, you got to spend 20. Plus what? Well, if X we'll say is the number of texts you're going to send. Exactly. You want to multiply X by the per text charge. You want to do 0.05 times X, which we can just write as just writing the X next to it. And that's automatically implied that we're doing 0.05 times X. Exactly. So that's how we can figure out the cost of the plan in terms of X. Well, here's something that we even like to do more. We usually like to write the variable first. So you can write it this way, it is correct, but we usually like to write the variable first. So let's do that. We'll put the constant over here. There you go. So that's the cost of the plan. That makes the cost of this plan, well, no matter what, I got to spend $5. I'm going to add that on. Now I'm going to say 10 cents, 0.1. You could even write 0.10, whatever your flavor. 10 cents per text, so it's 10 cents times the number of texts you're planning to send that month. Now, because you want to know how many texts it'll take for the two plans to have the same cost. That's our goal. What do you think we're going to do with these two expressions here? I want to know for what X value is this cost the same or equal to this cost? I want to set this thing equal to this thing. That's my goal. If I set the two equal to each other, then I can solve for X, and that is exactly the number of text messages I can send each month. So because you want to know how many texts it'll take for the two plans to have the same cost, set the two equal. Take 0.05X plus 20 and set it equal to 0.1X plus 5. Does that make sense? Why we set them equal to each other? What they represented in each case? So now we need a little bit of space. I'm going to go ahead and just delete this. Get on out of here. You can go. We'll bring all this up here to the top. And now we got ourselves a mighty fine equation to solve. Some of the things we're going to be doing, we're going to deal with decimals in a little later on. How do we multiply, divide, add, subtract decimal numbers? Because you'll notice we have them here. So let's do a little trick. Multiply both sides by 100. Why 100? Well, because this goes out to 2 decimal places. This only goes out to 1 decimal over here. But if I multiply this by 100, it moves the decimal over twice, and suddenly I get to deal with nice whole numbers. This will also get moved over twice, but whatever, that's fine. It's still just going to be a whole number. That does mean I'm going to need to multiply the 20 by 100 and the 5 by 100. So I'm going to multiply everything by 100. Now, in a little bit later on in this course, we're going to be able to deal with decimal numbers and adding them and subtracting them. But for now, let's not do it. So that means I move this decimal point over twice, and it just becomes 5x, 5.5.0x, or just 5x. The 20 actually becomes 2,000 because it got multiplied by 100. Then it's equal to the 0.1x. If I moved it over twice, now the x isn't really part of the number there. Remember that. So it's kind of like, it's a little sloppy, but that'll become 10x. And then the 5 becomes 500. It's the same equation in spirit, or rather, it has the same solutions. It has the same solution, so we're okay with doing it. Remember, one of our rules was we could multiply both sides of an equation by any number we want. So I picked 100 because it helped. It didn't help me, it didn't immediately solve it for me, but it just helped. And so now, let's solve it. We can subtract the 10x over. Oh no, we have to do negative numbers? Yep. That's life. So you can have negative 5x plus 2,000 equals 500. So the numbers are a little larger. Now we subtract 2,000 from both sides. Give myself a little more space here. You're going to end up with negative 5x equals 500 minus 2,000. Clearly we'll go negative. And then 2,000 minus 500 is 1,500. So negative 5x equals negative 1,500. That's good because that means that x is going to be a positive number, which is what we expect. You can't send negative 25 text messages. That's silly. So now we would naturally divide both sides by negative 5. The negatives would cancel. You'd get x just by itself. Negative 1,500 divided by negative 5. The negatives will cancel. 15 divided by 5 is 3. So 1,500 divided by 5 is 300. So in summary, if I send 300 texts per month, plans cost the same. If I send more, plan A is better for me. If I send more than 300, plan A is the better choice because you've already tied with plan B, but now if the per message, the text message were only 5 cents each after that point. So you're spending less per text after that. If I send less than 300, if I send 250, if I send 299, plan B is the cheaper of the two plans. Does that make sense? Cool. Let's go ahead and take our break here. We'll be back around 1:45, 1:40, 1:45, something like that. Okay, so I just took attendance, so you guys have been counted present if you're here. I can see all your names in the participants box in Zoom. Okay, so we solved this one. Let me go close the door real quick. So we're talking about applications of linear equations. So far it's been word problems. We set them up, get an unknown, solve for it, bada bing, bada boom. Let's see if there's anything else super interesting. Yeah, that might be interesting. Okay, so for this next problem, your local computer store, which those may not be around too much longer, we'll see. Your local computer store is having a terrific sale on digital cameras. I'm sure you guys would love to see what I'm doing here in the classroom, so let me turn that projector back on. There you go. So your local computer store is having a sale on digital cameras. Let's take a look back in history. A digital camera was like a phone that didn't have texting or calling in it. It was just a camera only. Yes, a digital camera, that used to be a thing. Maybe you use a digital camera. So now we all just use our phones, I think. Most of our phones are usually better. Anyways, after a 40% price reduction, you purchased the camera for $276. What was the camera's price before the reduction? Let's say we're not worried about sales tax. We're not going to worry about sales tax. We just want to know what the price is going to be after you get the nice discount, but before you apply any sales tax. Okay, so let's write out what all the variables and all the things here are. So you buy a digital camera. It was 40% off. The price now is $276. So the price right now, after you've applied the discount, is $276. What was the original price before you took the 40% off? All right. Well, let's see if we can figure that out. If we can solvify that together. So let's see. Let's let x be that unknown value, the thing that we're trying to figure out. So we're going to let x be exactly. It's going to be the original price before we applied the discount. Then we're taking 40% off of it. So we're actually going to do this one two ways. Two ways. Way one is just going to be the kind of straightforward way. The discount amount we're going to say that's the physical dollar amount we slashed off the price, that we took away from it. Now, we don't know what that physical amount is at the moment, but we can express it as a quantity in terms of x. If we took 40% off the top, then the amount we took off is 0.4, because remember, we convert 40% into a decimal whenever it's time to actually do your adding, subtracting, multiply, dividing, times the original price of the camera. That's how much we're going to be slashing off the price, 0.4 times x, the original price of the camera. That's our discount amount. And so now we can set up an equation. The sales price, the amount that we're actually going to be spending after the discount, we start with the original price of the camera minus the discount amount, minus 40% of the price of the camera. So that is subtraction here. Let's make it a little longer. That's what we're going to do. And then this is a decimal point. And so now what this quantity will give us is it's going to give us the actual amount we're spending on the camera after the discount. And that's supposed to come out to 276 because the problem provided us with that. Well, as it stands right now, we are dealing with decimals or dealing with something out to 1 decimal point. So let's apply our silly little method. Last time I had to multiply both sides by 100 because there was 2 total decimal points that some of the factors were going out to. But this time, I only need to multiply by what number? 10, exactly. And if I do that, I will get rid of all decimal points. The 10 applies everywhere. It applies here, it applies here, and it applies here. So it becomes 10x. Tanix was a boss in Destiny. Minus 4x equals, we got to multiply 276 by 10, 2760. And now we've cleared out decimal points. Do you have to do it? No. If you're comfortable with decimal points, then by all means, just go ahead, plow through it. We'll deal with decimal points ourselves a little bit later on. But now we combine like terms on the left-hand side. You're going to get 6x equals 2760. Nothing changed on the right. Now what do I need to do? Exactly, divide by 6. And we're going to do it by hand. Because, as you know, calculators aren't allowed on exams. So it's best to do this assuming we're not going to touch a calculator. So, divide both sides by 6. So I'm going to come over here and do that calculation. Give myself more space. 6 doesn't go into 2, but it goes into 27. 4, not 3 times, but 4 times. 9 goes in 3 times. Bring down the 6. 6 goes into 36 how many times? 6 times, exactly. Now you're tempted to say, oh, I've got a 0 remainder, but you haven't taken everything down from up here. You gotta do that before you can talk about remainders. So we bring that down. How many times will 6 go into 0? 0 times. And now we can say that this 0 here is the remainder because there's nothing left to bring down on top. And so that means that the answer is 460, which is the year I was born. It's up to you to decide if it was BC or AD. I'll give you a hint. It was BC. That's a stupid. What's that? Exactly, before Corona, yes. Those are the good years, the good times. I could sit down and eat at a restaurant. Now I don't do that. So yeah, the original price of the camera was $460. Let's try it a different way. And let's just think logically. Let's think. If I take 40% off, how much percent am I still paying? 60%. In other words, I can kind of skip to the fun here. The original price of the camera, I would have to take 60% of the original price. So I need to do 0.6 times X, and that'll give me the original 276. And that's the equation I can set up immediately. I can just say, okay, X is the original price of the camera. 60% of that is what I'm still paying. So if I do 0.6 times X, that'll give me what I'm still paying, which we already knew was provided to us as 276. And now I can solve for X, the original price of the camera. Here I still have a number out to one decimal place, so I want to get rid of it. I want to, sometimes it's called sweeping out decimals, getting rid of them. I would still multiply everything by 10. And look at that. You'll still get the equation. 6x equals 2,760, which is just what we solved a second ago over here. So of course it comes out exactly the same because it is exactly the same. And you're going to get the 460 we already got. So there's more than just one way to do these problems. If you're curious, you could throw tax in here. And now in Texas, tax is 8.25%, 8.25% sales tax. So you would take 8.25% of 460, whatever that is, add it on to 460, and that's your total price after tax. But we'll deal with that a little later on. How does that sound? Groovy? Good? All right. So that's going to wrap up this section of chapter 6. Let's go pull up the next section there, Pilgrim. Standing by. Give me one moment. I'll go ahead and pause the recording. Welcome back. Welcome to the future. All right. Let's do a little crash course. And I'm going to call it dealing with decimals. Not decimals, decimals. Now, what we've done here, we have converted between fractions and decimals already. We did that earlier in the semester. So 3/4, we figured out that it became the decimal 0.75 because for 3/4, we divided 4 directly into the 3. So we know how to convert between fractions and decimals. We know how to convert between decimals and percents. We then, by proxy, know how to convert between fractions and percents. 3/4 is the decimal 0.75, which in turn must be the percent, 75%. So we did all that. We're experts on it. But now let's do the 4 principal operations: addition, subtraction, multiplication, and the division. Let's do those and deal with decimal points in that case. Okay, so addition or subtraction. Addition or subtraction. Well, you're going to ultimately line the numbers up via the decimal point, and then add, subtract like normal, but put the decimal point on the same line or in the same place. But then you can add or subtract like old school addition subtraction. We put one number over the other, and then you put a plus sign or a minus sign, and you just line up all the digits in their proper places. So let's do some examples of that. Let's say you're doing 14.75 plus 26.321. So 14.75 plus 26.321. You know what? How many of you would like to make it interesting? Raise your hand if you want to make it interesting. Anyone? Make it interesting. Might as well. We're in class, or it's safe. It's better than making it interesting on the homework while you're out there in the wild. Let's make it boom, 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 boom. 514.75. Interesting, very interesting indeed. Oh no, Rangers. What are we gonna do? Well, okay, 514.75. When you're doing addition subtraction, you want to line the numbers up via the decimal point, and you want them to all be in the same place. So I want the hundreds column to line up. Now this one doesn't have anything in the hundreds column, which secretly implies there's a 0 there. The tens columns line up, the ones column, the tenths columns line up, the hundredths, and then the thousandths. If there's nothing there, again, you can assume there's a 0. So let's Adam, not Eve. So you start from the right. There's an implied 0 here, and perhaps I'll even make it ghostly to say, ooh, it's secretly there, but you don't have to write it. But we do want to think about it as being there in terms of actually doing the addition. And so now let's do it. Let's see, 1, 0 plus 1 is 1. I'm going to put the decimal point in the same place. I'm going to line it up. 5 plus 2 is 7. 7 plus 3 is 10, so it would be a 0. Carry the 1. And let's put it carry the 1 up there. Then I'm going to do 1 plus 4 plus 6, which is 11. So a 1, carry the 1. 1 plus 1 plus 2 is 4. 5 plus essentially 0, it all becomes 541.071. Could you just put that into a calculator and get the same answer? Well, yeah. Can you use calculators on your exams for this course? No, you can't. So there's not much value to be gained. If you're on your homework, yeah, you can just blast through it and say, yeah, just do it on the calculator. That homework is easy. And then you'll get to the exam and you will not be in a good way. So, yeah, we're teaching you the actual math itself. I'm not just teaching you how to punch numbers in a calculator, because that's just not how it works. It's not how math works. So there's that. Now we can, okay, so same idea. Let's do a subtraction example. Fun stuff. How about, what do I have cooking for y'all? How about one of y'all give me a number? Go ahead, give me any two numbers. You want to see one subtracted from the other. Go out to 3 or 4 decimal points as your leisure. Go ahead, give me a number. Nothing too hilariously massive, just for the sake of space. 126.75. Go ahead and give me another number. 348. 348.621. Let's put a little extra cheddar on there. Jason, I saw your suggestion, but someone else got theirs in first, so sorry, Jason. But I appreciate your effort. Thank you very much. Well, thank you. Now, the first thing you're going to notice, the first thing you notice, what will the sign of your answer be, positive or negative? It's got to be negative, exactly. I'm taking a smaller number and subtracting from it a larger number. So we know we can just kind of write to the side, my final answer is going to be a big fat negative. Once you know that, remember one of our strategies for dealing with subtraction is to actually take the larger number in absolute value and subtract the smaller number from it. So what we're actually going to be doing is 348.621 and subtracting from it 126.75. That's not what really is going on. We're going to assume that for now, and then we're just going to have to remember the final answer is going to be the negative of whatever we get here. Again, make sure your decimal point's lined up and you put it in the same place in the answer. And once you do that, the decimal point is almost just like an afterthought. And it's almost like we were subtracting the number 12,675 from the number 348,621, although not quite, not quite, we're close. So over here, we do 1 minus 0. Oh, we get 1. 2 minus 5, we can't do that, can we, Pilgrim? We're going to need to borrow from the 6 here, and we can call that a 12. And it's 12 minus 5, 7. 5 minus 7, well, you can't do that again there, Pilgrim. You're going to have to borrow from the 8. Negative 7, that becomes 15 now. 15 minus 7 is 8, exactly. Then the rest should go smoothly. What's 7 minus 6? What's 4 minus 2? What's 3 minus 1? 2 as well. So we get 221.871, but remember, that's not the actual answer, it's the negative of that. So just because you're dealing with decimal numbers, all of our rules for decimal addition, or all of our rules for addition, subtraction, they don't go out the window. They're still there. So we are comfortable with addition, subtraction. You kind of just do old school addition and subtraction. And yeah, bada bing, bada boom, that's how it is. That's how it's going to work. So we're dealing with decimals. Multiplication of decimals. Well, this one is a little bit more interesting. It's not just line up the decimal points. No, something weird, something kind of funky happens whenever you multiply decimal points, whenever you multiply decimal numbers. So what you can do is you multiply the numbers like old school, like the old school way, but the final answer will have the same number of decimal points as the total number of decimal points in the original numbers you were multiplying. Total meaning, if I'm multiplying a number that goes out to 2 decimal places by a number that goes out to 3 decimal places, 2 plus 3 is 5, my final answer is going to go out to 5 decimal places. It's a little bit tricky. And it's also not easy to see why in the heck that happens. So for now, we'll say it just does, but there's actually a good reason it happens. And I can demonstrate it mathematically if you're bored using fractions, but probably don't want to do that, but we could. We could. Okay, Jason, I feel bad because I didn't get your numbers earlier. So why don't you do this for me, Jason? Give me 2 numbers we can multiply. Make the first number, it can have like 2 digits, then a decimal point, and have 2 more digits. And then the second number, just have it be a number that goes out to 1 decimal place. So something like 23.65 times 5.8 or something like that works for me. What do you got for me, Jason? Jason. Sail to the ship Argo to get the golden fleece. 22.94 times 88.9. I like it, Jason. Thank you very much. Everyone give a round of applause for Jason. Everybody in the classroom too. Let's lift up our thunderous applause. We must be louder. No, we're not. Thank you, Jason. Thank you, Nicole, for congratulating Jason. Yes, very good. We will do that. But let me throw a little wrench into the mix because I like doing that. Let's do 22.94 as Jason suggested. We'll multiply it by, and so this is a dot, negative 88.9. Everyone gasp. No, there's no need to gasp. Do the rules get thrown out the window just because we're dealing with decimal numbers? No, I'm multiplying, claps in circular motion. Thank you, Slater. There we go. The rules don't get thrown out the window just because we're dealing with decimal numbers. I'm multiplying a positive number by a negative number. What kind of sign will the answer have? Well, a positive times a negative gives you what? A negative number, exactly. If they were both positive numbers, your answer would be positive. If they were both negative numbers, your answer would also be positive. But if one number is positive and the other is negative, doesn't matter which one, your answer is going to be negative. So I can just tell you right now, Pilgrim, my answer is going to be a negative sign. Once you've dealt with that, you can then kind of ignore the negative sign in the second number and just do the multiplying and not hurt your brain too hard. Now that I know it's going to be negative, I'm going to do 22.94. And here's the trick. You actually don't even have to line up the decimal points here. In fact, you really usually won't, because we already are going to have a system for dealing with the decimal point. So addition, subtraction, line up your decimals. Multiplication, no worries. It's because it's not going to matter anyways. Let me make sure I have plenty of space. Space Jam, which is like raspberry jam or grape jam made in space. Let's move this business up. Hey, you get back there. Just want to make sure everything looks good. So many things on the screen. You are bad. Oh my God. You go down there. Thank you. Thank you for work. Okay, so now we're going to do it. Sorry about that, technical issues. We know the answer is going to be negative, so now we're going to do it. And I'm going to use a slightly different color. How about orange? Let's see if that looks good. So if you remember your old school multiplication, you start over here with the 9, you multiply it through by everything here. So I do 9 by times 4 first. 9 times 4 is 36, so I put the 6 down there and I carry the 3. But now carrying the 3 is a little bit different. I do the 9 times 9 first, which is 81, and then I add 3 to it. I don't do 9 times 9 times 3. I do 9 times 9 plus 3, which is going to give me 84. So I put a 4 down there, and then I carry the 8. Now I do 9 times 2, which is 18. Add 8 onto that. And so 18 plus 8 is going to be 26. So I do the 6, carry the 2 for 26. And I do it again. I do 9 times 2, which is 18. 18 plus 2 is 20. And now there's no 2 to carry. I just write the 20 here. And remember, we're ignoring the decimal points for a moment. And I'll show you after we multiply where the decimal point needs to go. That's what we're going to do. We also are ignoring the negative sign because we know the final answer will be negative. All right, so I did orange. Now I'll do like a maroon. Now you have to clear out these numbers up here because they only applied for that first thing. Now it's a new day. Remember though, whenever you get to your second row, every time you go to a new row, you add another 0 at the end than you did before. So here, there's going to be a single 0 there. And then I can go over. And why that 0? Why is that 0 there? It's because I'm not actually multiplying by 8. I'm actually multiplying by something like 80. If you pretended there were no decimal points, say it was 2,294 times 889. The first row I multiplied by 9, but technically the second row I'm multiplying by 80. But all I can say is that, well, that's just 8 times that and then times 10 again, so that 0's for that extra 10. But if you just remember it as a general rule of thumb, it won't hurt you. So put a 0 there, and now do 8 times 4 is 32, carry the 3. 8 times 9 is 72 plus 3 is 75. And remember, you got to know that 12 by 12 multiplication table like the back of your hand. 3 times 6 is 18. 7 times 9 is 63. 7 of 9 is a board character from Star Trek Voyager. 6 times 12 is 72. Things like that. You got to know, you got to be quick with that standard 12 by 12 table. Anywho, so this 8, then we did 8 times 9 plus 3, we got 75, so 5 down here, carry the 7. Now we do 8 times 2, which is 16. 16 plus 7 is the number 23, a very stupid Jim Carrey movie. Then 8 times 2 is 16, plus 2 again is 18. Excuse me, plus 2. So we get that. New color, how about pink? Hopefully it shows up well. Now I need to put, it does, it's like a nice dark pink. Now I put 2 zeros to start with that one. I go 1 more 0 than I did in the previous row. And that's because it's kind of like I'm doing 800 now. I can get rid of those numbers along the top because they don't no longer apply in this case. And now I do it again. 8 times 4 is 32. Carry the 3. 8 times 9 is 72, plus 3 is 75. 8 times 2 is 16, plus 7 is 23. 8 times 2 is 16, plus 2 is 18. It's really just a reproduction of these numbers, except everything shifted 1 more over to the left. And now I do addition. Now I deleted the decimal points, so let me rewrite them here. We'll worry about the decimal in just a moment. Now we need to do addition. I add these, so 6 plus 0 plus 0, 6. 4 plus 2 plus 0, also 6. 6 plus 5 is 11, plus 2 is 13, so I'll put a 3, carry the 1. 1 plus 3 plus 5 is 9. 2 plus 8 plus 3 is 13, carry the 1. 1 plus 1 plus 8 is 10, so 0, carry the 1. 1 plus 1 is then 2. Okay, so is our final answer going to be 2,039,366? Heck no, because about a number that's about 23 times a number that's about 89, it's not going to get into the millions. You may not know it off the top of your head, but I can tell it's not in the millions. Here's where we need to use this rule here. The final answer will have the same number of decimal points as the total number of decimal points in the original numbers you were multiplying. This guy had 2 decimal points. The second guy had 1 decimal point. I add those. 2 plus 1 is 3. So the final answer is going to have 3 decimal points. So I need to move this over, and it's going to have to go right there. So that now this final answer has 3 decimal points. I'll take a swig of water. Is it hot in here to anyone? Is it hot in here? Are you guys fine? It's okay, it's fine? Okay. Do you know that women tend to get colder a lot quicker than men? But there's actual scientific research behind it. Women tend to like the thermostat set about 5 degrees higher than men do, because I don't know why, but it's just kind of interesting. Certainly at my house, I keep it really cold, and my girlfriend hates it. And I tell her, I say, well, then we'll just go halfway in between. What you want and what I want, we'll just go halfway. And she says, yes, that is a fair and equitable way to handle that. And I say, yes, it is. And there's no drama behind it because we worked out a solution. We compromised. Great story. All right. So is our final answer 2,039.366? Almost. But remember, the final answer needs to be negative. So the real final answer, and this is with no rounding. 2039. There's no rounding. If a problem doesn't say round, don't leave off the decimals. Don't only round to 1 decimal point. No, no, no. Put it all there unless it says otherwise. Okay, so we've done addition of decimal numbers and subtraction of net decimal numbers. You line up the decimal. We did multiplication. You don't line up the decimal there. Now let's talk about division. Tom Clancy's The Division. And I referenced that. That's a video game. Division of decimal numbers. Here's the rule you're going to follow. First, write your division using the old school method. So this is kind of what the old school method would look like. That is equivalent to saying 12 divided by 3 equals 4. Or 12 divided by 3 equals 4, written as a fraction. This is the old school way of doing division. This is the new school way of it. You damn kids, and you're doing things the different way than the way I did it when I was coming up in school. And then finally, this is the fraction method. Of course, this is the only real method that lets you actually like do it. Like here, you're just kind of doing it off your head. Here, you're also kind of just doing it off the top of your head. And that's easy if it's just 12s and 3s and 4s, but if it was something nasty, this is the way you're really thinking to do it if you have to do it by hand. You write it out, and then you have a process for doing division. So I call it the old school method. Maybe it's not all that old because technically we're supposed to know it kind of coming in here. So first, write your division using the old school method. Next, line the decimal of the quotient. Remember, the quotient is the result of division. Line the decimal of the quotient up with the decimal of the, we called it the dividend. So for instance, if we were doing 4.2 and we're dividing it into 126.79, then this here, this is the dividend, excuse me. This is the dividend, the thing that's being divided. And then the quotient is the thing on top. We would line up their decimal points now. And then we would do the division, and you'll see what kind of adjustment we're going to make in just a moment. So that's how you would do it, but we're actually going to change it up just a little bit. Whoops, whoops. Just kidding. You're going to line the decimal up, yes, in a moment, but before lining up, move the decimal of the divisor over however many times it takes to no longer have a decimal number. Move the decimal in the dividend that many times as well, even if you still have a decimal in the dividend. And it's a lot of words for what's going to end up being actually a pretty simple process here in a moment. So what do I mean? Well, we did 4.2, we divided it into 126. I don't remember what we had, so I'll just make up something new. 0.33. Well, according to the rules, we want the number, the decimal point in the divisor, this guy here, the 4.2, we want it to go away. So we can move the decimal 1 point over to the right. I can't just arbitrarily move the decimal point unless I also do it here. Then things will work out. So it's almost like I'm really dividing 42 into 1263.3. So now there's no longer a decimal in the divisor. There's still one here in the dividend, but there's nothing we can do about that, except we could even make that 420 into, and we can move it over again, but we're not going to do that. And so then I would line up my decimal. But then once I do the division, I've dealt with the decimal point. So then I just do division as if I was dividing 42 into 12,633. Does that make sense? Decimal point's already been taken care of. So let me not speak in a high-pitched voice randomly. Actually, my voice just cracked there. And you're saying, Josh, are you secretly like going through puberty? Are you a teenager here? I thought you were a grown man. I was like, no. How many of you have ever seen the movie Jack with Robin Williams? Jack? It's a little bit older, so probably not. It's about a movie. It's a movie. A 10-year-old boy has some kind of weird condition where he ages 4 times faster than he should. So he looks like a 40-year-old man, which is played by Robin Williams. He's actually a 10-year-old boy. I actually have that. That's not true, I don't. But, did I make the joke that I was 19? Was it with y'all I made that joke? Yeah, I said I was like, I'm 19 years old. No, I'm not 19. I'm a little bit older. I'm 20. Okay, so let's actually do some dividing. Let's make an interesting one. And sometimes these are going to get ugly. Sometimes these are going to get a little bit ugly. Well, there's nothing we can usually do about that. Let's do 26. And by 26, I actually am going to mean 0.26. Let's divide that into 89.7. Now, I could have written that a different way. If you just had a problem on an exam and it said do 89.7 divided by 0.26, don't freak out. Come go and write it here in the old school way, and that's how you can actually deal with the numbers. Or even if I did 89.7 divided by 0.26, if I did it that way. Don't freak out, calm down, and just write it in this manner. Write it in the old school way. Old school is almost not even a good term for it. It's if you actually have to do division by hand. What's that? Yeah, long division is exactly the other way to write it. If you ever had to do division by hand, you're just calling it long division. That's because you have to do it. Most of us, we would prefer to just pop it into a calculator, but you know what? We don't always have that luxury in this life. Okay, so according to our rules, this here, the dividend, it's 2 decimal points. It goes out to 2 decimal points. So I'm going to move the decimal 2 places to the right. And then it's going to become, you could say it's like 0.26 or 26, but now that 0 in front is no longer necessary. 0.26 is just 26. Now, the dividend, the thing inside the house, I don't move it 1 decimal because that's what it would take for it to no longer have a decimal point. I move it the exact same number of spots that I moved this one. So this one I move it the number of times I want. This one has to move that same amount whether you like it or not, whether it leaves you a decimal point or not. And that means I need to fill a 0 in here. So in actuality, the division I'm doing is 26 into 8,970. Everyone say cool. And now we can say it's gone. And then I would line up the decimal points, but the decimal point is now kind of gone, but secretly that means it's right here. And so I'd line it up above. And now, well, I don't have a calculator. Just gonna have to do this the hard way. 26, I need to figure out how many times it goes into 89. Oh boy. Let's see if it goes in twice. So I would do 26 times 2, and you get 52. Okay, so you're trying to basically get 26. You're trying to find the largest number here so that it stays under the 89 in this case. It's as large as it can without going over. I bet I can do, what's that? It'll be 3, yeah. I bet I can go up one more. If I do 26 times 3, 18, carry the 1, 3 times 2 is 6, plus 1 is 7. 78 is going to do it. Because I bet if I went 26 times 4, oh, that's going to go over 100. That's going to end up being 104. So 26 times 3 is going to do it. So that 3 is what goes here. Does that make sense? Kind of long division. So it's assumed you've seen some long division before, and all we're doing today is we're kind of sorting out long division and decimal points. Does that make sense? That's kind of our goal. So these no longer are necessary. It was just side calculations we did to make the division work out. All right. So maybe I should have left it up there. Remember, 26 times 3 was 78. So I'm going to do minus 78. And then 89 minus 78, do a quick couple of, what's that? 11. Then I bring the 7 down. And, oh gosh, the fun starts again. I got to figure out how many times does 26 go into 117. I bet it won't do it cleanly. It'll do it 4 times. Yeah, we already figured out that 26 times 4 was 104. If you try to go one more, if you try to do 26 times 5, that's going to come out to 130. And I'm just kind of quickly going through the multiplication. And 130 is too big. It's past 117. So we got to stop here. Put 4 there. Subtract 104. Get 13. Carry this 0. Oh, it's perfect, isn't it? Yeah, we already figured out 26 times 5 is 130. So 26 goes into 130 5 times. In fact, it does so cleanly. And then since there's nothing left to carry down, we have a 0 remainder. Are we done? Yeah, we're done. Now the decimal point, you could say 345.0, but that's just the same as 345. So lining up the decimal there ended up not having any real conflict. Do y'all want to see me work something else? You want me to do it? Do y'all want to see me in the Zumosphere? You can let me know. Do you want to see me work another division problem with this long division and the dividing and things? Now you have to be careful because you can't just give me any number you want divided by any other number. And I mean, I can do it, but it's going to get nasty quick, and it's expected on your exams that the numbers won't get that nasty. So you have to engineer the problem a little bit smartly so that it comes out a little bit clean. So Jason, you want me to see me work another one? You got it, my friend. So let me engineer one right quick. Ooh, what might be interesting? What might be an interesting one to engineer? How about we do 39.048 divided by 1.2. And you know what? Let's make it a little bit. No, let's do that. Let's do that. That's fine. Okay, actually, no, let's make it interesting. Let's make it negative 39.048 divided by, exactly. So just throwing a negative sign in here, is that gonna really royally screw everything up? No, it just means you gotta remember, your rules don't change. That's a big takeaway. Just because you're dealing with nasty, ugly decimal numbers doesn't mean that the rules magically are upended. You still are dividing a negative number by a positive number. My process tells me the answer is going to be negative. Once you know that the final answer then needs to be negative, you can kind of relax writing the negative sign when you're doing the actual math behind it so you don't confuse yourself and cluster up the screen. So now I can just do 1.2. I don't want to do red. Let's do a more interesting color. How about purple? That looks good. It's a nice dark purple. 1.2, and we're going to divide it into 39.048. We already know the sign will be negative, so I won't put the negative sign here, because I've already dealt with it. If I was doing negative 39.048 divided by negative 1.2, what would the sign of that answer be? Positive, exactly. A negative divided by a negative becomes positive. So my first step is actually to take care of the decimal point. Remember, your divisor needs to be kind of like a nice whole number. So I need to move it one place to the right, which means I also move this decimal place just one place. I don't move it all three so that this is also a nice clean number. We don't often get that luxury. And so now what it becomes is 12 into not 39.048, but 390.048, or excuse me, 390.48. And now we'll line up the decimal points. Give myself a little more space. I might have to write a little smaller than I did in the last case. Okay there, Pilgrim, let's try it out. Let's just do it. How many times will 12 go into, well, it won't go into 3, but it'll go into 39. How many times? 3 times. Very good. 12 times 3 is 36, so it's going to be minus 36. I'll have to write a little smaller. What's 39 minus 36? 3. Now I'll carry that 0. How many times will 12 go into 30? 2 times. 2 times 12 is 24. The decimal point's already taken care of, so we just bring the 4 down. How many times will 12 go into 64? 5 times. 5 times 12 is 60. And carry the 8. How many times will 12 go into 48? 4 times. And actually it does so nice and cleanly. And there's nothing left to bring down up here. There's nothing more to bring down. We got a 0 remainder. We're done. Almost. Exactly. The answer is going to be negative 32.54. And that's my answer. What if it didn't get clean? What if there was like a 2 left here? Oh no. Remember, I can always throw zeros on the end after my decimal points already happened and bring it down. So now that would become 20. I could do 12 into 20. And remember, you'll have to just see if there's a repeating pattern that happens. You'll have to keep going until either you see it terminate or you figure out what the repeating pattern is. Now that wasn't the case here, but it's just nice to know that even now, they're not always going to come out clean. This one did, but it's not guaranteed to happen. For the last thing, let's talk about rounding. Let me draw up a quick diagram. Rounding numbers, there's times to do it, there's times to not. A time for love and a time for hate. Let's say you had the number, and I'm going to write it nice and big. Oh, 3, 4, 6, 5, 2.7148. Let's say you had that number. Let's do some social distancing with the numbers. Space them out a little bit. Let's remember what each of these places are called. And remember that big fat decimal point there. This first one here is called the ones place. It's the number just immediately to the left of the decimal point. This is called the tens place. Because when you're saying 50, what you're really saying is 5 tens. This is the hundreds place. Because when you're saying 600, you're really saying 6 hundreds. This is thousands. Okay, then it just kind of repeats. Then 10,000. Oh my gosh. And then you could keep going. If you kept having numbers getting larger and larger, you'd have 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, trillions, 10 trillions, 100 trillions, quadrillions. If you never knew that, that's the number. That's a quadrillion is 1,000 trillions. I think it's pentillion or quintillion, I think, after that. Now, numbers after the decimal place always end in THs, not T.H. White, the author of Once and Future King. So this is the tenths. I'm even going to use a lowercase. Tenths. This is hundredths. A nice TH at the end. This is the thousandths place. This is the 10,000. Nope. Ths place. And then it keeps going after that. 100,000ths. Well, then millionths, 10 millionths, 100 millionths, and so on. So remember well how these places work, because we're about to appeal to that here with rounding. Ooh. So I'm going to delete this. You don't have to reproduce it perfectly. It's not that important. How to round. First, figure out your rounding digit, aka the digit to be rounded. Figure out which one it's going to be. If a problem says round to 3 decimal places, then go out to that third decimal point, which would be the thousandths, and that's your digit to be rounded. Look at the digit immediately to the right of it. If that digit is a 4, or let's just say, if that digit is a 0 to 4, round down. This means you just delete all the digits starting to the right, the immediate right of the rounding digit and beyond. if that digit is a 5 to 9, round up. This means add 1 to the rounding digit, then clear away everything to the right of the rounding digit. So you've probably dealt with rounding before. That's good. Let's do an example. Let's remember our little friend pi. No, let's not do pi. Let's take the number 355.6127984. Round this number to the nearest third decimal point. The nearest 100. Oops. And how about the nearest, let me think, 100,000th. And let me just alter the number a wee little bit. Let's make that one a 2. So 325.6127984. So first, we want to round this to the nearest third decimal point. Well, all right there, Pilgrim. The nearest third decimal point, this is the 2 here is the third decimal point, right? That's 3 decimals. So what I'm going to do is I'm going to draw a line in the sand. This is the rounding digit, this 2 here. But I'm going to look 1 digit immediately to the right. This is going to be the one that tells me, it helps me figure out how to round, but it's about to go away. Now, this digit immediately to the right is a 5 to 9. So I round up. I add 1 to the rounding digit, and I clear the rest away. So everything before the rounding digit stays the same. 325, or usually will stay the same. 0.61. The 2, I add 1 to it to get 3, and then the 7984 is gone. It's cut off. Does that make sense? That's how I round to the nearest third decimal point. Now let's round to the nearest 100, not hundredth. And that would actually be this 3 here. That would be this 3 here. So I draw my line in the sand. I look at the digit immediately to the right of it. So am I going to be rounding up or down? Down. So I don't add 1 to the 3, I just leave the 3 alone. And so it's going to be 3. And then everything else to it goes away, kind of. Technically what I'm doing is I'm putting zeros in for everything else. So it'd be 300, then my decimal point. Then I can put a 0 in for the rest of these numbers. Up here I could have done the same thing. That's technically what I'm doing. But then those zeros on the right don't matter because they already happened after the decimal point. But up here, so it's going to be but now anything after the decimal point That's a terminating 0. I mean, it's not necessary. And the decimal point itself isn't necessary. So it would be 300. Finally, the nearest 100,000th. All right, let's see. 10th, 100th, 1,000th, 10,000th, 100,000th. So it's this 9. It's this 9. Then I look over to the digit over, and it's an 8. So am I going to be rounding up or down? I'll round up here, which means I add 1 to the 9. Uh-oh, SpaghettiOs. What's 9 plus 1? 10. So it actually adds 1 to this. It flops back over and adds 1 to the 7. But the digit to be rounded is still represented. So here's what I'm going to do. 325.612. It adds 1 to the 7, but there still needs to be a 0 there for that 9. And then I can put zeros for the 8 and the 4 as well that have now been deleted or swept away. But since those zeros happen at the very right after the decimal point, it's good. So the number 325.6127984 rounded to the nearest 100,000th is 325.6128. So secretly, there's a 0 here, but it wasn't necessary. So actually, that's the best I could do. That's actually technically like rounding it to the nearest 10,000th, but there was nothing we could have done about that. That's just how it happened. Okay, I think that's a good time for us to call it for the day. Be sure to check your homework, do your online homework. I'll be uploading some new stuff. I'll be uploading it today, and then we'll have another exam next week, but I'll make a formal announcement about that on Thursday. How does that sound? Thank you, guys. Y'all have a great day. Thank you.